Tractors built America's farms, fed generations, and turned raw prairie into productive land that sustained the nation. But for decades, these machines harbored deadly secrets, features that seemed practical, innovative, or simply normal until the body count became impossible to ignore. Today, we're counting down 11 tractor features so dangerous they were banned forever. From exposed power shafts that grabbed clothing in milliseconds, to rollover risks that crushed operators, from extra rider seats that threw children into wheels, to exhaust systems that turned routine mowing into infernos. These aren't just design flaws. These are features that killed farmers, maimed workers, and destroyed families until regulations, retrofits, and industry pressure finally eliminated them from fields and factories. This is the story of agricultural machinery that proved too dangerous to continue, of features that seemed acceptable until the accidents mounted, and of an industry that eventually prioritized safety over tradition when the cost of doing nothing became unbearable. Number 11. High-power PTO engagement without safeguarding. The 11th feature that was banned takes us to implement engagement systems that delivered full torque at the PTO, or power takeoff, with no soft start or adequate shielding, creating situations where sudden torque spikes snapped driveline components and threw debris violently. The PTO transferred engine power to implements through rotating shafts, spinning at 540 or 1,000 RPM, creating rotational forces capable of destroying equipment and injuring operators when engagement happened too quickly or without proper safeguarding. The danger came from instant engagement, where full engine torque hit implements suddenly rather than gradually, creating shock loads that could shatter universal joints, snap driveline shafts, or break implement components that weren't designed to handle the violent forces that instant engagement created. The broken components became projectiles flying at operators or bystanders with enough force to cause severe injuries or death. When metal fragments struck exposed skin or penetrated cab structures that weren't designed to withstand high-velocity impacts. The whip hazard was equally terrifying, with driveline shafts breaking and flailing violently when torque loads exceeded their design limits, creating rotating metal whips that could strike anything within their radius before the operator could shut down the engine or disengage the PTO. The guards that were supposed to contain these failures often shattered themselves when struck by flailing metal, sending additional debris flying and creating cascading failures, where one broken component destroyed multiple systems simultaneously. Modern standards address these dangers by requiring guards capable of containing failures, soft start engagement systems that gradually brought implements up to speed rather than hitting them with instant torque, and interlocks preventing engagement when conditions weren't safe. The improvements saved lives by eliminating the sudden violence that had characterized PTO engagement on older tractors, where full power arrived instantly, and operators had no time to react when things went wrong. Number 10. Operator presence and neutral interlock omissions. Early tractors that could start or move implements without operators present or with gears engaged take 10th position for creating runover situations and unintended motion that caused severe injuries when unmanned tractors moved unexpectedly. The lack of operator presence controls meant tractors could be started while in gear, creating situations where machines lurched forward as soon as engines fired and caught operators or bystanders who were standing near the tractor expecting it to remain stationary until someone climbed aboard and deliberately engaged motion. The dangers multiplied when operators dismounted temporarily to check implements or adjust settings while leaving engines running, creating situations where inadvertent contact with controls could engage motion, or where vibration could cause shift levers to move from neutral into gear positions. The unmanned tractors would then move forward or backward without warning, running over the operator who had stepped off expecting the machine to remain stationary, or crushing anyone who happened to be working near the tractor during the unexpected movement. The children on farms were particularly vulnerable, with curious youngsters climbing onto tractors, left idling unattended and accidentally engaging controls they didn't understand, creating tragic scenarios where youngsters were injured by machinery they'd activated without realizing the consequences, until motion began and they panicked rather than shutting down engines or disengaging controls. The parking brake failures compounded the dangers with worn or improperly adjusted brakes, failing to hold tractors on slopes, allowing gradual rolling that accelerated as gravity overcame friction and created runaway situations where unmanned tractors gained speed until they crashed into buildings, equipment, or people who couldn't escape the path of multi-ton machines moving faster than anyone could run. The linkage wear on older tractors created situations where transmission controls would slip from neutral into gear positions without operators touching anything, with worn detents and stretched cables allowing levers to move from vibration or engine torque, acting on internal components until gears engaged and motion began unexpectedly. The cold weather exacerbated problems with hydraulic fluids thickening and allowing controls to creep from positions where operators had set them, creating delayed engagement, where tractors would sit motionless for minutes before suddenly lurching into motion as hydraulic pressure built or as components warmed enough for mechanisms to overcome resistance and complete engagement. The distraction factor was significant, with operators focused on implements or adjustments, believing they'd left tractors safely in neutral, but having inadvertently bumped shift levers or left transmissions in gear without realizing the mistake until they heard engines bog down or saw tractors moving toward them. The investigative reports from fatal runover incidents repeatedly documented that victims had dismounted with engines running and been caught by unexpected motion, creating patterns so consistent that safety authorities concluded that eliminating operator absence starting and motion was essential to preventing the predictable tragedies that occurred with disturbing regularity across agricultural operations. The psychological impact on families who lost members to runover accidents was devastating, with survivors haunted by the knowledge that simple procedures like shutting down engines before dismounting or ensuring neutral selection before starting could have prevented deaths that resulted from momentary lapses or from trusting that equipment would remain stationary when that trust wasn't justified by mechanical reality. The PTO engagement without operator presence was equally dangerous, with implements suddenly activating when no one was controlling the tractor, creating hazards for people working near rotating equipment that they believed was safely shut down. But that could activate if controls were bumped or if mechanical linkages shifted from vibration or settling. The injuries ranged from minor to fatal, depending on what part of the body contacted moving implements, and whether victims could escape before being pulled into rotating components or struck by moving parts. Safety fact sheets and industry practice now demand operator presence controls that prevent starting unless the operator is seated and transmission is in neutral, plus interlocks that automatically disengage PTOS and stop motion when operators leave seats. The systems use pressure switches, detecting when operators are seated, and transmission position sensors, ensuring neutral is selected before allowing engine starting, eliminating the runover hazards that killed operators throughout agricultural history. Number 9, minimal road use, safety equipment. Tractors operating on public roads with inadequate lighting, reflectors, or no slow-moving vehicle emblems take 9th position for creating collision hazards that killed farmers traveling between fields or returning home after dark. The SMV, or slow-moving vehicle, emblem is the fluorescent orange triangle with reflective red border that warns motorists that vehicles ahead are traveling substantially slower than normal traffic speeds and require caution during passing or approach. The lighting deficiencies were severe on older tractors with minimal reflectors, dim incandescent bulbs, and no conspicuity lighting, making them nearly invisible at dusk or night when visibility was already limited. The rear-end collisions were common and often fatal. When cars traveling at highway speeds approached tractors moving at 15 or 20 miles per hour on dark rural roads, with drivers unable to judge closing speeds until collision was unavoidable because they couldn't see the slow-moving tractors until dangerously close. The documentation was grim, with fatality statistics showing that rear-end strikes were among the most common tractor-related deaths on public roads, with the highest incident rates occurring during dawn and dusk hours, when visibility was poorest and speed differentials between tractors and other vehicles were most extreme. The injuries to vehicle occupants were often severe because modern cars weren't designed to impact the massive rear axles and implements that tractors carried, creating intrusion into passenger compartments that proved fatal even at moderate speeds. Modern road safety standards require SMV emblems, prominently displayed on any vehicle incapable of maintaining minimum speed limits, plus conspicuity lighting featuring amber flashing beacons visible from substantial distances, and mirrors allowing operators to monitor traffic approaching from behind. The requirements were written in blood, implementing solutions that should have been standard decades earlier, but weren't mandated until the body count became politically impossible to ignore and public pressure forced regulatory action. Number 8. Rotary and alternative rear suspension systems, causing instability. Non-traditional rear dampers and suspension geometry on some heavy machines meant to modernize ride control take 8th position for creating instability and wobble that could escalate dangerously, forcing manufacturers to withdraw designs and revert to conventional suspension when safety complaints surfaced. The rotary dampers and alternative geometries seemed innovative on paper, promising better ride quality and more consistent performance across varying loads and field conditions, compared to conventional systems that agricultural engineers had relied on for decades. The instability emerged during transport and high-speed operation when loaded implements and uneven surfaces created forces that the alternative suspension couldn't manage predictably. The oscillations would begin subtly, but could build into violent tank slappers, where the rear axle swayed side to side with increasing amplitude until operators lost control or were forced to stop and allow the oscillations to dampen naturally before continuing at reduced speeds that kept movements within manageable ranges. The frequency of the oscillations matched natural resonance points in the tractor's structure, creating harmonic feedback where each cycle reinforced the next until the entire machine was shaking violently enough to throw operators from seats or cause structural damage to frames and mounting points not designed to handle the extreme lateral forces. The implement weight acted as a pendulum, amplifying the oscillations with heavy equipment swinging behind the tractor, creating momentum that the suspension couldn't control, making tractors with large balers, tillers, or grain carts particularly susceptible to developing uncontrollable wobbles that felt like the entire machine was trying to tear itself apart. The steering became nearly impossible during severe oscillations, with operators fighting to maintain straight-line tracking while the rear axle was moving several feet side to side, creating situations where the front wheels were pointed straight, but the tractor was traveling at angles because the rear was sliding rather than tracking behind the front as conventional suspension would ensure. The tire wear was accelerated dramatically by the lateral scrubbing that oscillations created, with rear tires developing irregular wear patterns and suffering sidewall damage from the repeated flexing and stress that occurred during episodes of instability that subjected tires to forces they weren't designed to withstand. The operator fatigue was severe, with the constant corrections and physical effort required to maintain control, during transport creating exhaustion that reduced alertness and increased accident risk, as tired operators made mistakes or failed to react appropriately when oscillations began building toward dangerous levels. The highway transport became genuinely hazardous, with tractors experiencing instability at road speeds, where loss of control could result in crossing into opposing traffic lanes, running off roadways into ditches, or jackknifing when oscillations caused implements to swing wide and pull tractors sideways during the violent motions. The customer complaints were numerous and consistent with operators reporting that the alternative suspension made tractors genuinely frightening to operate at any speed above slow fieldwork, creating reluctance to transport equipment between fields and forcing some operators to trailer tractors rather than drive them on roads where the instability could prove fatal. The engineering analysis revealed that the alternative suspension designs had failed to account for the complex load dynamics and center of gravity variations that agricultural equipment created, with computer modeling that looked promising under simplified test conditions proving completely inadequate for predicting real-world behavior, where multiple variables interacted in ways that created instability the designers hadn't anticipated or considered during development. The danger multiplied when operators were towing heavy implements or traveling on crowned roads where subtle slope changes affected weight distribution and load transfer between wheels, creating asymmetric forces that alternative suspension systems couldn't balance effectively. The conventional suspensions had evolved through decades of field experience and thousands of hours of testing, creating proven designs that might have been less sophisticated but were predictable predictable and safe under the wide range of conditions that agricultural use demanded. The withdrawals were embarrassing, but necessary when manufacturers acknowledged that innovative designs had created problems worse than the ride quality issues they were meant to solve. The reversions to conventional suspension represented engineering humility, admitting that sometimes traditional solutions existed because they worked reliably, even if they weren't the most theoretically advanced approaches available. Number 7. Exhaust routing and designs, linked to tractor fires. Exhaust systems that leaked or heat-soaked critical components under normal use take 7th position for causing multiple tractor fires during routine service, with independent investigations tying root causes to exhaust side design flaws that forced fleets to sideline over 100 machines. The fires occurred primarily on highway mowing tractors, where extended operation at high engine loads created exhaust temperatures hot enough to ignite adjacent components, fuel lines, or hydraulic systems that weren't adequately shielded from radiant heat or direct contact with exhaust manifolds. The design flaws were subtle, with exhaust routing that seemed adequate during initial testing but proved inadequate during sustained real-world operation, where heat buildup accumulated over hours of continuous mowing rather than the shorter test cycles that manufacturers had used during development. The critical components affected included fuel lines running too close to exhaust manifolds, hydraulic hoses positioned where exhaust heat degraded rubber compounds until they failed and sprayed flammable fluid onto hot metal, and electrical wiring with insulation that melted from prolonged heat exposure until bare conductors shorted and created ignition sources. The investigation findings were damning, documenting that the fires weren't random failures or maintenance issues, but systematic problems, traceable directly to factory designs that hadn't adequately considered worst-case operating conditions. The fleet managers faced impossible choices between continuing to use potentially dangerous equipment that was essential for maintaining highway right-of-way vegetation or sidelining over 100 tractors and disrupting operations critical to public safety and roadway maintenance that couldn't be deferred without creating hazards for motorists. The spotlight on how normal factory designs could become mass hazards changed industry practices regarding heat management and component placement, forcing more rigorous testing protocols and stricter requirements for thermal shielding and separation distances between heat sources and vulnerable components. The lessons extended beyond agriculture into construction equipment and industrial machinery, where similar exhaust-related fire hazards existed but hadn't received adequate attention, until agricultural fires demonstrated the consequences of inadequate design consideration. Number 6. Hazardous hitching and drawbar crush zones. Exposed hitching points and drawbars without protective design or safe procedures take 6th position for creating situations where operators were pinned or run over while coupling implements, with fatalities occurring regularly during hitching and unhitching operations that seemed routine but were genuinely deadly. The hitching process required operators to position tractors precisely in relation to implements, often backing toward hitches that couldn't be seen directly and required judgment based on mirrors or estimates that weren't always accurate. The crush zones existed between tractors and implements, where operators positioning themselves to insert hitch pins or connect hydraulic lines could be caught if tractors rolled backward unexpectedly, or if implements shifted from settling or from slopes that weren't immediately apparent. The pinning injuries were severe, with the massive weight of tractors and implements creating forces that crushed limbs, torsos, or heads within seconds before operators could escape or bystanders could intervene to stop motion and free trapped victims. The runover scenarios were equally deadly when operators dismounted to guide hitching and tractors moved unexpectedly from parking brakes failing, transmissions slipping from neutral, or slopes causing motion that parking systems couldn't prevent on surfaces that were too steep or too slippery for brakes to hold reliably. The victims were run over by tractor wheels or struck by moving implements, sustaining injuries that were often fatal because of the massive weights involved and the lack of protection when human bodies contacted agricultural equipment designed to move earth and crops rather than to operate safely around people. Guidance now mandates safe hitching zones marked on equipment, wheel chocks preventing unwanted motion, and strict procedures requiring engines shut down and keys removed during hitching operations, where operators must dismount and position themselves in locations where unexpected motion could trap them. The requirements acknowledge that hitching will always involve some risk, but seek to minimize hazards through procedures, equipment design, and training that emphasizes the genuine dangers that routine operations create when safety protocols aren't followed religiously. Number 5. Narrow tricycle front ends. Too closely spaced front wheels used on many row crop tractors take 5th position for creating high center of gravity with narrow front track that made side slopes and ruts treacherous. dramatically increasing rollover risk, until wide front conversions and design phase-outs followed as rollover data mounted. The Tricycle configuration featured a single front wheel or two wheels positioned close together on a narrow axle, creating distinctive appearance that was common on row crop tractors through the 1950s and 60s, when the design seemed practical for cultivating crops planted in narrow rows. The instability was inherent in the geometry, with the narrow front track providing minimal resistance to sideways tipping forces, while the high center of gravity amplified those forces during operation on slopes or when turning with heavy implements, creating momentum that wanted to continue straight while the tractor was turning. The combination meant that relatively modest side slopes could cause rollovers, and ruts or furrows could catch narrow front wheels and trip tractors into rolls that wider front ends would have resisted through their greater track width and stability. The rollover statistics were grim, with Tricycle front tractors involved in disproportionate numbers of fatal rollovers compared to wide front tractors operating in similar conditions. The data showed that the narrow front track wasn't just slightly less stable, it was genuinely dangerous in ways that killed experienced operators who understood the risks, but couldn't always predict when combinations of slope, momentum, and terrain would exceed the tractor's stability limits and send it rolling sideways or backwards. The wide front conversions became common retrofits, with dealers and aftermarket suppliers offering conversion kits replacing narrow front axles with wider versions that dramatically improved stability and reduced rollover risk. The design phase-outs followed as manufacturers acknowledged that Tricycle fronts were inherently dangerous and that row crop farming could be accomplished with wide front tractors that were safer, even if they required different cultivation techniques and implement designs accommodating the wider stance that stability demanded. Number 4. Unshielded fans, belts, and rotating driveline components near the operator. Early designs that left cooling fans, belts, pulleys, and driveline parts largely exposed take fourth position for creating contact and entanglement hazards that led to amputations and severe trauma when operators or bystanders came into proximity with rotating components that should have been guarded. The exposed locations placed these components within reach of operators performing routine checks, adjustments, or maintenance while engines were running, creating temptation to reach across or near rotating parts that seemed harmless until clothing, hair, or hands contacted spinning components. The fan blades were particularly dangerous, with metal blades spinning at engine speed, creating cutting edges that could sever fingers or hands that contacted them accidentally. Plus, the risk of blade failure, where centrifugal forces broke blades that then became projectiles flying at high velocity toward anyone standing near the front of tractors. The belt drives connecting engines to cooling fans, alternators, or hydraulic pumps created pinch points where loose clothing or gloves could be grabbed and pull hands into moving belts and pulleys faster than operators could react. The driveline components near the operator station included clutch housings, transmission input shafts, and PTO drives that were sometimes only partially guarded or not guarded at all, creating situations where operators climbing onto tractors or performing maintenance could contact rotating parts that would grab clothing and pull bodies toward machinery with forces that human strength couldn't resist once entanglement began. The injuries were severe because the rotating components didn't stop when they encountered resistance. They continued spinning with full engine torque, pulling victims deeper into machinery until someone shut down engines, or until victims were torn free by forces that caused traumatic amputations or fatal crushing injuries. Modern guarding requirements address these hazards by mandating covers and shields over all rotating components accessible during normal operation or routine maintenance, with interlocks preventing removal of guards while engines are running and warning labels identifying locations where removal of guards for service creates hazards requiring engine shutdown. The regulations acknowledge that complete guarding is sometimes impractical, but require that hazards be minimized and that remaining risks be clearly communicated through labeling and operator training. Number 3. Extra rider seats and platforms. Small bolt-on or built-in pads and platforms inviting second persons onto open tractors take third position for creating situations where bumps or turns threw riders off into wheels or implements, with safety authorities documenting fatal runovers from this practice that seemed harmless but was genuinely deadly. The extra rider accommodations ranged from simple fender-mounted pads to elaborate platforms with handles, creating appearances of legitimacy that made the practice seem acceptable despite the genuine dangers that unrestrained riders faced on vehicles never designed to safely carry passengers. The ejection scenarios were common with riders lacking seatbelts or any restraint system to keep them aboard. When tractors hit bumps, turned sharply, or accelerated suddenly, the riders would be thrown from tractors and land on the ground where they could be run over by rear wheels that operators couldn't see or couldn't avoid because stopping distances exceeded the space between where riders fell and where wheels would follow. The runovers were often fatal because tractor wheels weighed thousands of pounds and created crushing injuries that were unsurvivable when they rolled over torsos or heads. The implement hazards were equally severe when riders fell backward off tractors and landed on or were pulled into trailing implements, featuring rotating components, sharp edges, or crushing mechanisms. The injuries ranged from lacerations and fractures to complete dismemberment or death when riders contacted equipment designed to cut crops, till soil, or bale hay, rather than operate safely around human bodies that had no business being near the machinery. The prohibition emphasis in modern training materials is absolute, with no extra riders being among the most fundamental safety rules in agricultural operations, supported by documentation of fatal accidents and by liability concerns that make carrying extra riders uninsurable and legally indefensible when injuries occur. The message is clear. Tractors are designed for single operators in protected locations, and anyone else aboard is at genuine risk of injury or death, regardless of how short the ride or how careful the operator believes they're being. Number 2, no ROPS and no seatbelts. Tractors sold for decades without roll bars, protective cabs, or seatbelts take second position because rollover is the leading cause of tractor deaths, and without ROPS, or rollover protective structures, and seatbelts, operators are crushed or ejected when tractors tip. The statistics are staggering, with rollover accounting for approximately half of all tractor-related fatalities, making it the single deadliest hazard that agricultural workers face, and creating body count that justified the eventual requirements that ROPS become standard equipment on new tractors, and that retrofits be strongly urged for older machines lacking protection. The physics of tractor rollovers are unforgiving, with the high center of gravity and narrow wheelbases, creating instability that can send tractors tipping sideways or backwards faster than operators can react. The backwards rollovers are particularly deadly, occurring when front wheels encounter obstacles or when pulling heavy loads uphill, creates situations where weight transfers rearward until the tractor pivots around the rear axle and flips completely over, often landing on the operator if they haven't been thrown clear or haven't had time to jump. The ejection deaths are common when operators without seatbelts are thrown from tractors during initial tipping, creating false hope that ejection represents escape until the victims land on the ground where the rolling tractor crushes them as it completes its roll. The survival statistics show clearly that operators who remain within ROPS protection and are restrained by seatbelts survive rollovers at dramatically higher rates than operators who are ejected or who attempt to jump, proving that staying with the protected zone is safer than trying to escape. Even though instinct tells operators to jump when they feel the tractor tipping, modern tractors pair ROPS with seatbelts by requirement, recognizing that the two systems work together with ROPS, providing protected space that prevents crushing and seatbelts keeping operators within that protected space during rollovers. The retrofit programs offer subsidies and incentives, encouraging farmers to install ROPS on older tractors that were manufactured without protection, acknowledging that the cost of retrofitting entire fleets is substantial, but justified by the lives that will be saved when rollovers occur and operators remain protected rather than being crushed by machines weighing thousands of pounds. Number 1, unshielded PTO shafts. The number 1 feature that was banned takes us to exposed power takeoff shafts, transferring engine power to implements without guards or master shields, creating entanglement hazards where loose clothing, hair, or hands could be pulled into rotating shafts in milliseconds with catastrophic injuries or death. The PTO shaft rotates at 540 or 1000 RPM, depending on the setting, creating rotational speeds where anything that contacts the spinning shaft is grabbed instantly and wrapped around the shaft faster than human reflexes can respond. The entanglement dynamics are terrifying, with the rotating shaft acting like a drum, winding up anything that touches it, wrapping clothing, hair, or limbs around the shaft in fractions of a second, and pulling victims toward the shaft with forces that increase as more material wraps and creates leverage pulling bodies into machinery. The injuries are severe because the wrapping continues until clothing tears, limbs separate, or the engine stalls from the resistance, meaning victims experience multiple rotations being struck by the shaft, implements, or ground while trapped in the machinery. The clothing hazards are particularly insidious because loose jackets, untucked shirts, or dangling drawstrings can contact spinning shafts without operators realizing it until the wrapping has already begun and escape is impossible. The farm culture of working in layers with heavy coats during cold weather creates additional risks when bulky clothing makes it difficult to judge clearances, and when material catches on shafts that operators didn't realize they were approaching closely enough to contact. The split-second nature of entanglement means that by the time operators feel the initial tug on their clothing, the shaft has already completed multiple rotations, wrapping material tightly enough that pulling away is impossible, and the momentum of the wrapping process is dragging victims toward the machinery faster than they can react or call for help. The long hair worn by many farm workers creates similar hazards, with hair contacting spinning shafts and being wound up instantly, pulling victims by the scalp toward machinery with forces that can cause severe neck injuries or scalping trauma, even if bystanders manage to shut down engines before complete entanglement occurs. The gloves commonly worn during farm work become deadly when they catch on shafts and trap hands that would otherwise slip free, with the fabric gripping the rotating surface and pulling hands into pinch points between shafts and guards, or wrapping fingers around shafts with enough force to cause traumatic amputations. The recovery operations after entanglement incidents are gruesome, with emergency responders required to carefully reverse engine rotation or cut away clothing and machinery to free victims who've been wrapped multiple times around shafts, creating psychological trauma for rescuers who witness the severe injuries that PTO entanglement creates within seconds of initial contact. The mandatory guarding requirements that emerged from decades of fatalities specify master shields covering the entire length of PTO shafts from tractor to implement, plus input and output guards at connection points, preventing access to rotating stubs that remain exposed when implements are disconnected. The guards are required to rotate freely around the shaft rather than spinning with it, creating smooth surfaces that deflect contact rather than grabbing clothing or limbs like exposed shafts do. The enforcement is strict, with OSHA, or Occupational Safety and Health Administration, regulations requiring guards and penalizing operations found using tractors or implements with missing or damaged guards that leave shafts exposed. The liability implications are severe, with operators or owners facing legal consequences when injuries occur on equipment lacking required guards, creating incentives beyond regulatory compliance for maintaining guards, even when they seem inconvenient or when operators believe they're experienced enough to work safely around exposed shafts. The education emphasis in agricultural safety training always highlights PTO hazards as among the most deadly features of farm equipment, using graphic documentation of injuries and fatalities to communicate that the dangers are genuine and that guards aren't optional conveniences, but essential protection against machinery that can kill in the time it takes to realize you've made contact. The message has evolved from suggesting guards are good practice to making absolutely clear that operating unguarded PTO equipment is deadly gamble with odds that eventually result in tragedy. These 11 banned tractor features prove that agricultural machinery harbored deadly hazards for generations before regulations, industry standards, and safety consciousness finally prioritized operator protection over tradition, cost, or convenience. From unshielded PTO shafts that wrapped clothing in milliseconds to rollovers that crushed operators without ROPS, from extra riders thrown into wheels to exhaust systems that turned tractors into infernos. These were the features that killed farmers until the industry acknowledged that some traditions were too dangerous to continue. Which banned feature shocked you most? Share your thoughts below. Subscribe now. More agricultural history and safety stories coming soon.